Hold on. All right, so for number 15, so we have two people, Milo and Tony, pulling up a tree stump. I felt like I've done this question before. Well, anyhow, so we have a tree stump right here, and then we have Milo pulling it at 145 pounds. That's a force. And then Tony with a force of 160. Okay, 160 pounds, and then the angle in between these two is 24 degrees. What would be the magnitude of the resultant? Now, again, whenever you see the word resultant, I think if you took physics already, or if you are taking physics this year, I think whenever you see the word resultant, you can immediately ask yourself a question. Head to tail? Are the vectors connected from head to tail? In this case, based on the diagram that I drew, is it head to tail? It says not. And if it's not, then we say, well, let's go ahead and fix it. Let's do so let me go ahead and move the vectors like this. I'm still going to have this one. Well, actually, let me do this way. Let me make the first one horizontal. Okay, so the next one it's slanted like this. So 145 pounds, 160 pounds, like this. Now I'm going to move the 160 pounds right here. And the question is, what is this angle? What's this angle? (156 degrees). Okay. And then I would draw my resultant from the beginning to the end. And I'm going to make a major disclaimer right here. Okay. I'm going to make a major disclaimer right here. Okay. Let's go through that question first. How do you know it's 156? Well, it's a parallelogram, so this is 24 degrees. Okay. Now I'm going to make a major disclaimer, and the disclaimer is that some students, when I was grading the last test, some students they were looking at this angle. And you know what they assumed? They assumed that this angle is, well, either they assume that's 24, which is wrong because that big angle is 24, or they wrongfully assume that this is 12, which is half of 24. It's not divided by 2. The diagonal is not an angle bisector. Okay, it's not 12 degrees. And the other thing is, we don't care actually, because if I want to find the magnitude of the resultant right here, well, I think we got what we need to find out the resultant, because we have the two sides, and then we have the big angle right here, which is 156. We can do law of cosine, law of cosines, which is we can have x equals to the square root of 160 square plus 145 square minus 2 times 160 times 145 cosine of 156 degrees. Yes. So that's a good question. Can you move the 145 pound vector instead of 160 pound? That is absolutely okay. Okay, that is absolutely okay. So if you say initially I have this drawn, and then I have this is 160 pounds, and this is 24 degrees, and you move this up 145 pounds. That is perfectly fine as long as you know that this is 156 degrees. And you can tell this is 156 degrees. Actually, there are two ways you can tell. You can say, well, this is 24 because of alternate interior angles. Or if you remember for your parallel lines, same side interior are always supplementary to each other. So they add up to 180. So 180 minus 24 is 156. So either way, you get your same degree measure. So with this, I'm going to calculate. If you need a calculator, get a calculator first. 160 square. So 160 square plus 145 square minus 2 times 160 times 145 cosine of 156 degrees. And let me make sure that it's in degrees. All right. And then let me go ahead and add a multiplication sign right here. And then that's the one that's squared. So I need to take the square root. So raised to the 1/2 power. So the magnitude is 298.351. So the magnitude is 298.351 pounds. So when they pull together the resultant force, it's going to be 298.351 pounds. Okay. So again, you will, now when you see the resultant vector, you ask yourself, is it head to tail? If it's not, make it happen. Number one. Number two, when you draw the diagonal, make sure you do not assume the wrong thing. I love students, they use the law. Well, what happened is this. They assume this angle to be 12 degrees, and then they use law of sines. I would say, no, it's not 12 degrees. Second, you've got all the information to use law of cosines. Use law of cosines. Okay.